This is problem number 2. So Claire asks Andre to play the following number puzzle. So pick a number, add 2, multiply by 3, subtract 7, add your original number, whatever number you picked in the beginning, add that original number, and Andre ends up with a final result of 27. So what number did Andre start with? So here are the steps written out algebraically. So pick a number x, add 2, multiply this value right here by 3. So you have to multiply the whole thing by 3. So 3 times x plus 2. Subtract 7 from all of this, and then add x back. So whatever x is, you add it back, or you add it again, and you end up with 27 as your answer. So to work backwards, you can't work backwards exactly, because if you say, okay, now I'm going to subtract this x, you don't know what you're subtracting. So you have to get these x's together in some way, and some single value that you can subtract from 27 to figure out what x is. So to do that, we're going to use the distributive property. So if this is 3 times x plus 2, if I have 3 x's plus 2's, then I have 3 x's, and I have 3 times 2 is 6. So 3x plus 6, sorry. Now subtract the 7 from that, add x, and that equals 27. So now I can combine the 6 and this negative 7. So you're going to add negative 7. That's going to equal negative 1, and I can combine this x with this 3x. So that's going to equal 4x. So now I can get this down to 4x plus 6 minus 7 equals 27. And 4x plus a negative 1. So remember, this is subtracting a positive 7. So that's the same as adding a negative 7. So you're going to use the inverse operation and use the additive inverse. The inverse operation is addition. The additive inverse is a negative 7. So this is the same thing. But it's just easier for me anyway to add 6 plus a negative 7 in the middle of this. So I'm going to add negative 1. And that equals 4x plus a negative 1 equals 27. So this is 1 less than 4 times this number. So this number then is 4 times this number is 28. So 27 is 1 less than that, because it's 4x plus a negative 1. So I have to add that 1 back. So that takes me from 27 to 28. So now I have 4x equals 28. So 4 times whatever number I chose equals 28. That means the number I chose was 7. So now I'm going to go through, I got a little bit tongue-tied in that, sorry. But now I'm going to go through some different ways of thinking about this. I could say, oh, we're done, we're finished. But I want to push the idea of trying to make a drawing of these problems to help you think through it, and just see different ways that you might try to solve it. That helps you figure out what to do if you run into trouble. Maybe you go down the wrong path or a more difficult path. Can you fight your way through it? Can you figure out how to get out of that? But first of all, let's look at this number puzzle in a little bit more detail. So I have 3 times x right here, and I have another x over here. That means I'm going to end up with 4 x's. Somehow, whatever I do, I'm going to end up with 4 x's. 3 times this x plus this x over here. I'm also going to end up with negative 1, because I'm going to end up with 6 right here. 3 times 2 is 6, plus a negative 7. So I'm going to add negative 7. So I'm also going to end up with negative 1. So I'm going to have 4x plus a negative 1 equals 27. So that is, in words, that is 1 less than 4 times the original number. Now what if you play around with this a little bit, and rather than 7, let's say that you use 8 as x. Well, what's 4 times 8 is 32. Or 9 as x. 4 times 9 is 36. And the puzzle gives you the relationship of 1 less than 4 times this number. Well, what's 1 less than 28 is 27. What's 1 less than 32 is 31. What's 1 less than 36? It is 35. And notice that all of these differ by 4. Because you're multiplying by 4 times 7 is 28. 4 times 8 is 4 groups of 8, but that's 4 times 7 plus 4, one more in each group. Or 4 times 9 is 4 times 7, you want to go back to the 7, plus 2. Or an extra 2 in each group. So that's going to be 8 different from 28. So there are some relationships here, and that's all I'm trying to point out to you. And so if it's 1 less than each of these numbers, so the final for this value, if you choose 7, is going to be 27. If you choose 8, it's going to be 31. If you choose 9, it's going to be 35. All right, so to make a drawing of this problem, you just start out. I'm going to start at 0, and it says pick a number, that's x. So here's x right here. I don't know what it is. I'm just going to put it on the number line. And then I'm going to add 2 to that. And then I'm going to multiply that by 3. So I'm going to have 3 times x plus 2. So I'm going to have 3 of these. X plus 2, x plus 2, and x plus 2. Then I'm going to subtract 7. But I don't know where I am right here. I don't know what this value is. Whatever it is, I'm going to subtract 7 from it. Then I'm going to add x back, and I'm going to end up at 27. So at this point, I got stuck. I didn't really know how to use this diagram to help me solve the problem. And so what I did is I did do some more algebra to help inform me how to work through this diagram. And then the diagram helps me, again, work through how to solve the puzzle. So I'm going to go back and forth here a little bit. And again, I'm going into a little bit too much detail, but I think you have to see different ways of solving these problems and different struggles that people can have. Now, this on the left looks tough because it's really using quite a few fractions, and it's kind of a mess because I chose really the wrong path. It is a path that gets the answer. You get down here to the answer, x equals 7, but it's a more, let's say, a more difficult path. Not really the wrong path, but a more difficult path. I'm going to show you what happens if you choose to use the distributive property first. So on the left, I'm not going to use the distributive property. I'm going to say, well, I have 3 times some number plus x, and this equals 34. I can add a positive 7 to this negative 7 to make this 0. I add that positive 7 out here to make this 34. All right, so now I have 3 times x plus 2 plus x equals 34. If I decide, okay, I'm going to take 1/3 of this. I'm going to just look at x plus 2. I'm going to divide this by 3, so this becomes x plus 2. The thing to remember is if you choose to that path, then you have to divide each term. This is called a term. This is a term. This is a term. Now, this is not simplified, but it is a separate term than this x. And the 34, of course, is on the other side. That's also a separate item or a separate term in the problem. You have to divide each of those by 3. You can't just divide this one by 3, but you also have to divide this x by 3 and the 34 by 3 to keep everything balanced. If I'm going to decide I'm going to take 1/3 of 3 times x plus 2, I also have to take 1/3 of x and also have to take 1/3 of 34. So now I'm at x plus 2 plus x divided by 3 equals 34/3. So it gets a little bit tough, and you can just work through this. If you look at it and think about it, it becomes more understandable. So now I have x plus 2 plus 1/3 x. So x divided by 3 is the same as 1/3 x. This is multiplying by the multiplicative inverse of 3. Inverse operation is multiplication. Multiplicative inverse of 3 is 1/3. So it's the same as 1/3 of x. And that equals 34/3. All right, so I want to combine this x plus this 1/3 x. Well, this x is 3/3 x. Combine them together, you get 4/3 x. And that equals 34/3 plus a negative 2. I want to get these x's together, and I want to get this 2 onto the other side because I want to end up with x equals something. So I can add the additive inverse of a positive 2, which is a negative 2. I'm going to also have to add that additive inverse to this side. So that's where that -2 comes from. So 34/3 plus -2. Now, 3/4 of 4/3 is 1. So think about that for a second. I'm going to multiply by the multiplicative inverse of 4/3, which is 3/4. 3/4 of 4 things are 3 of those things. So 3/4 of 4/3 are 3/3. Well, 3/3 is one whole piece, one whole x in this case. So this becomes x. But I also have to multiply each of these terms by 3/4. So 34/3 times 3/4 plus a -2 times 3/4. Now this is long, detailed, hard, kind of, gee, I don't want to think about this. But if you try to fight through it, you'll begin to understand the math in more detail. And none of this is too hard for anybody to understand. You can all understand this stuff. So this equals 34/4. These 3's become 1. So 3/4 of 34/3 is 34/4. A little bit hard to visualize. Plus a -6/4. -2 times 3/4 is a -6/4. Combine these together. 34 plus a -6 is 28. 28 divided by 4, or 28/4, is equal to 7. Now that was tough. Now if I took a different path, a less difficult path, by simplifying this term right here first. So by simplifying, that means to get rid of the multiplication, to rewrite this only as addition. So that means 3 times x plus 2 means I have 3 x's plus 3 times 2 is equal to 6. So this ends up being 3x plus 6. It's using the distributive property. I have this x I have to add to it, and this had become 34 because remember I added this +7 to get rid of this -7. You have to add +7 to 27, that equals 34. This is a lot easier to deal with. So I have 3x plus x is equal to 4x. So I have 4 x's. 3 times 2 is 6. That equals 34. So now I know what to subtract from this 34, which equals 28. And then 1/4 of 28 is equal to 7. So that told me in my drawing, I have to look at the distributive property. I have to use the distributive property. So I have 3x plus 2. So I have 3 x's, I have 3 2's, and I have one more x out here. Well, that 3x plus 2 is 3 times x plus 2 is 3x plus 6. So this right here, 1x, 2x, 3x, plus 2, 4, 6. So 3 times x, 1x, 2x, 3x, plus 3 times 2, 2, 4, 6. Now this is 3x plus 6. And I'm going to add one more x to that. So that tells me out here, this is 4x plus 6. Well, how much is that equal to? Well, if I subtract whatever it is, if I subtract 7 from that, or I add -7, I'm at 27. So this is 4x plus a -1, because I added a -7 to the 6, brought me back to 27. So if I just add 1 back to this, I get rid of this -1. This is 1 less than 4 times the number. Well, I'm going to add that 1 back. This is going to be 28, and 4 times whatever x is equal to 28. That means that x is equal to 28 divided by 4. So 28 divided by 4 is 7. So here's the 27, and here's the 34 out here. I never did say that, but this gets you out to 34, and you can see that in that this is 4x plus 6, and that equaled 34. That's right here. 4x plus 6 equals 34, because when you added that 7 to get rid of this -7, this became 34. So this 4x plus 6 is out at 34. And if I subtract the 6 from that, I actually end up at 28. But the problem said to subtract 7. All right, so this is long, a little bit too detailed. Maybe I went into too much detail, but think about it, give it a shot, try to work through it.